Okay. Well, there's probably a lot of people to thank. ADM put a lot of dollars behind this, and with the interest here, I think it speaks for itself that this is an exciting time. And last April, I guess in 2011, I came across Adam's poster down at Plains Nutrition Conference, and I called Galen when I got back and I said, "What is this?" And he started explaining to me what they were doing, and so I started thinking about it more, doing more calling, trying to figure this out if we could commercially do this. And I had a customer that I work with, and he was interested in trying it. And so we got some standard quick lime from Mississippi Lime, and we're mixing in a Rotomix 620. And we quickly found that we could put only about 2,000 pounds of corn stalks in that, and then add the calcium oxide and the water, and that was all we could do. If we couldn't get the mix otherwise, and so we said, well, this is probably not going to work for us because it's just not going to be feasible. We need the feed trucks to be able to feed and those things. So we started thinking, and I started trying to figure out how to use calcium oxide and get it, with us being in a liquid business, Performance Plus, it's not uncommon for us to induct stuff material into liquids, so had some knowledge there. So that's kind of what I started playing with, and so that's where I would caution everybody is I've played with this and have made some mistakes. So I hope that none of you can play with this and make mistakes, because it is a dangerous chemical that is exothermic, and will start stuff on fire. So, but with managing it and those types of precautionary measures, I think it is a reasonably safe method or application that we're able to do. So again, we've been commercially doing this since January, approximately January 1st. So we have cattle that have been on this whole procedure for the whole time, closing them out. We are excited with what we're seeing, very close to what we feel like the university has demonstrated. The things that I think that are important are probably the particle size. As you'll see, the machine that I am using is much different than a typical hay grinder with screens. It has no screens in it. It actually is a hammer mill, so we can grind very wet material through it without plugging it, and so somewhat unique. And hopefully we'll be able to. And with this uniqueness, we actually probably the product that you'll see is different. It has longer pieces of corn, like the leaves, but the stalk itself is really into really small pieces. So we somewhat think that we're probably getting a much smaller particle size than probably a 1-inch grinder, very similar. So that's excitement that we see versus having to run through a typical screen of 1 inch. So I got 3 videos from the places that we're currently doing this application, and 3 of the guys are in the room today. I'm not going to point them out, but I thank them for I know that they were about ready to kill me a couple times maybe or throw me out, but they worked hard, and we continue to problem solve, and now we've kind of come to a scenario that is fairly user friendly. So I'm going to start with probably the easiest method right now. In this scenario here, we actually, the machine is off to the left, and I just had filmed these. I didn't really necessarily film them to be able to present to you, but I had them. So what we have here, this machine here is RotoGrind. It is manufactured in Greeley, Colorado. There's two different types. There's a 760 model and a 1090. We're using the 1090. It handles much more material and able to grind. So in this scenario here, I think I'm just going to start playing it. We are taking back there in the my left corner, your guys' right corner, I guess. We are actually bringing ground corn stalks into the feed yard and taking. You see the other payloader going back there and getting the ground corn stalks. And then we're dumping it into the machine, into the rotogrind. And this is our apparatus here. I might pause that right now. You can see we have a water line coming in. We're running approximately, depending on how fast we're grinding, we can run 65 to 70 gallons of water through this. And then we have manufactured these machines to be able to disperse the calcium oxide. We're using calcium oxide. We're currently taking super sacks of calcium oxide. You'll see a lot of the guys have been using 50-pound bags. We started off with that. We went to the super sacks. That's been a much better or easier way to handle it. It's taken about a half hour of our time breaking those bags, and literally in a minute you can have that thing full. And this will run for about an hour, about 70 minutes typically. And so then we're piping that, once we've added the calcium oxide to it, we're actually making it calcium hydroxide at that point and taking that solution and I guess you would say injecting it into the hammer mills. And so what we're using this machine is for particle size reduction as well as mixing. So when we get a product out, we have a wet product. So so this is blowing out, and so what we're doing here, this product here is a week old. He does it in a week time frame. So every week he is processing his feed. We're feeding off the one pile. The new pile is what we're pushing up. So we're driving it with a payloader. We're packing it some. We're not going to great extents. It probably is what silage packing is, but really getting along quite well in this scenario. So this is by far the easiest way that we've done so far. $50 dry matter. In this scenario, yes, pre-ground through a typical hay buster. I think 3-inch screen here or 5-inch screen. So, and the guys are in the room. I don't know if you want Cody Macken, Tad Thomas, and Brett Baxter. So if you guys see their name tags, you can talk to them. But hopefully they'll be around. They will be around. And two of the guys are actually from Sterling, Colorado. So.
How many dry tons per hour?
Dry tons an hour. In that scenario, we can run about 22 to 23. We can change a little bit how fast we're running, and but in that scenario, if we get going too fast, we actually will plug the machine. So our max capacity is probably going to be about 23 ton an hour through this type of system. Dry matter. Yep. This is the second scenario. Now we're using what you saw, the same system as what ADM was using with a hay picker, and so we're running it through the hay buster prior to the application of the and again, this goes fairly slow but you'll get the point. So again, we're going right into the rotogrind, using that as our mixer, and applying the calcium oxide or calcium hydroxide at that point. Yeah, I am up there high, so. Again, at that speed, that's very similar to what we were doing with the payloader, but we're just skipping the step of the payloader. But we do have to slow down the hay grinder in that scenario. a little bit. Wasn't much, but we're keeping the rotogrind completely full. So, and then this is really, the next one is what we really started on, and this is what we'll demonstrate today, is actually 2 rotogrinds put together. Just being able to use one, it just is too much to put all the water on there and get the particle size reduction. I would like to just tell you that we could do that. I mean, I think if you wanted to make a larger particle size product, you could do that, but I think there's a lot of value in that smaller particle size. A lot of value. And I think you see that with the wheat straw, just being treated and being able to be treated probably better than what the corn stalks, and with the data of the 3-inch versus the 1-inch, that 1-inch screen probably responds very close to the wheat straw. So, we're actually currently doing a commercial study with this too. So we are excited to I guess demonstrate the process and make sure that we can say that the same process works. So we're putting the round bales in the rotogrind. We have tried square bales. The square bales being so densely packed is very difficult to actually get consistent flow. And we've had just, probably the rotogrinds are a little bit hard, aren't maybe never necessarily built to do the square bales. So that may be disadvantage of this scenario. That was pretty quick. I don't know if everybody saw that, but I'll run that again. But we'll be demonstrating this today. So I have both of these machines set up. So. And that's probably a very good point to point out, that he asked what the water needs are. You need 70 gallons per minute, and a lot of feed yards don't have that or have area. So in several of these locations, we actually drilled new wells to be able to do this. So just to make it easy. I mean, we made the commitment to do this, and you can make it very difficult, and it doesn't work. So we made it so it was easy to do. And at this particular feed yard, we're actually storing it for 30 to 40 days, and again, driving on and get along really well. So the resources at a particular feed yard are probably very important to this type of application. So, yes, Mike?
Your application of the machine, is that an adapter or is it a metering device?
Yeah, we have a control with water flow, and then yes. Then we have an inductor as well, and then we're regulating how many pounds of calcium oxide are going into the inductor on an hourly basis or minute.
Doing that, does that work better at 0 degrees?
Does it work better at 0 degrees? Well, we were pretty fortunate on the weather this year that we didn't have to really battle cold weather. But for the most part, on cold days, we got along quite well. You know, when you add the calcium oxide to the water, it heats up, so you really don't have much freezing going on. When the product is coming out, it's steaming, so you have some time to work with it before it freezes again. So.
Every time I do anything with those type of pipes you had temporary type of, those leak a little bit.
We've been able to. You'll see some leaking over here today, but for the most part, you probably want to be on some cement and those types of things. Don't want to be on mud or on dirt because you will leak some water. But for the most part, it hasn't. We've got to a point where we've been able to control the leaking of the water. So, yes.
With your mixing machine, why couldn't you put that into the big grinder rather than going into the rotor?
The water. You know, I guess he asked, can we put the solution into the grinder, and I think the difference between the two is the screens are below the knives, so the product has to go through the screens. So when you're wetting the product prior to going through the screens, your plug. And so we can take wet material and run these through there. So we're actually putting in that number 2, or the 2 systems, we're actually putting some calcium oxide into the machine.
Belt,
On the belt, and that's what done in that. So
couldn't you do that with your machine?
the calcium oxide, and yes, we could. And we also, you could take, if you don't have a good water source, we can take a reservoir of water. You know, if you have 5,000 gallons, be able to pump the water through and control your water that way. So,
Other questions for now? Again, you'll have a chance to see this, we think.
if it's not raining too much, but
Okay, thanks, Casey.
thank you.